For 80 years, we have been living in a ghost story. Astronomers knew something was out there, something massive, something that held galaxies together like the cosmic glue. But no matter how hard we looked, we saw nothing. We called it dark matter. It makes up 85% of the matter in the universe, yet it doesn't emit, absorb, or reflect light. It was the ultimate invisible man of physics. We could see its gravity, but we couldn't see it. But today the story changed. A series of groundbreaking papers trending across the scientific community has just confirmed that the James Webb Space Telescope has done the impossible. By using the universe's very first short-lived stars as cosmic flashlights, JWST has effectively rendered the invisible visible. We aren't just guessing where dark matter is anymore. We are looking at its shadow. We are looking at its halo. And what we are finding is rewriting the history of the Big Bang itself. Today, we explore how JWST just changed everything. To understand why this discovery is so massive, we have to look at the problem JWST was sent to solve. In the year 1970s, the Vera Rubin noticed something wrong with the galaxies. The stars at the very edge were orbiting just as fast as the stars near the center. By all laws of physics, these outer stars should have been flung into deep space, unless there was a massive invisible halo of matter providing extra gravity. We realize that the universe isn't just a collection of stars, it's a skeleton of dark matter. Galaxies are just the flash hanging on those dark bones. But because dark matter doesn't interact with electromagnetism, meaning light, it remained a mathematical ghost. Until now, our best way of seeing it was through the gravitational lensing, watching how light from distant galaxies warp around invisible mass. But that's like trying to see a pan of glass by looking at the distortion of in the room behind it. You see the effects, but you don't see the structure. Webb was designed to see the first light, and doing so, it accidentally found the first dark matter. The research trending today focuses on a phenomena called the caustic transient. Here is a breakthrough. JWST is a powerful enough to see individuals, incredibly bright stars from the first billion years of the universe. These are population 3 stars, the first born the cosmic in the cosmos. They were massive, hundreds of times larger than our sun. They lived fast and died young. Because they were so bright and existed in very center of the universe, the first pocket of gravity, they are perfectly positioned. As the light from these short-lived stars travel towards JWST, it passes through dark matter halos that surrounded the first galaxies. Scientists found that the light doesn't just warp, it flickers and magnifies in a very specific pattern. By analyzing the sparkle of these ancient stars, astronomers have successfully mapped the clumpiness of the dark matter halo. For the first time, we aren't just seeing a blurry smudge of the gravity, we are seeing the fine-grained texture of the dark matter itself. It's like walking into the pitch black room and lighting a single match. For a split second, you don't just see the flame, you see the shape of the walls, the light hit, and those stars that JWST matches. But the discovery goes even deeper. Some of the latest data suggests that some of these early stars might not be the stars at all, at least not stars like our sun. Enter the theory of supermassive dark stars. Standard stars are powered by nuclear fusion smashing atoms together, but theorists have long wondered if the very stars were powered by the dark matter annihilation. If the dark matter particles are their own antiparticles, they would annihilate when they collide, releasing massive amount of heat. This could create a dark star, a giant, cool, puffy object that could grow to be 1 billion times the mass of our Sun. JWST has recently identified 3 objects in the deep field known as JDES, JSZ13-0, Z12-0, and Z11-0. Originally, we thought they were galaxies, but now the spectral analysis suggests they might be these single monstrous dark stars. If this is confirmed, it means dark stars isn't just passive observer of the universe. It was the engine that powered the first light we ever saw. This brings us to the most controversial part of the new research, the shape of the universe. For years, the leading theory was cold dark matter. It predicted that the first galaxies should be round, clumped together into a blob. But JWST looked back and saw something weird. The earliest galaxies are elongated. They look like pickles or bananas. This has led scientists to a wild new possibilities, which is fuzzy dark matter. Instead of heavy particles, what if the dark matter is composed of ultralight particles that act more like the waves? These waves would interfere with each other, creating filaments of strings rather than clumps. This would explain the pickle of the galaxies. They are growing along the strings of a vibrating dark matter web. By seeing the shape of these galaxies, JWST is effectively reading the signatures of the dark matter waves. We are moving from a universe that is clumpy to a universe that is vibrating. We are currently in the golden age of the cosmology. For nearly a century, we were like people trying to finish a puzzle with 85% of the pieces missing. We could see the picture on the box, but we couldn't see the pieces in our hand. JWST has finally turned on the lights. By finding the very stars, it found the dark matter they live in. By finding the dark stars, it may have found the very origin of the black holes. And by seeing the pickle galaxies, it's telling us what dark matter is actually made of. The invisible man of the universe has finally left a footprint in the snow, and we are just beginning to follow the trail. If you want to keep up with the latest JWST discovery and the secrets of the deep cosmos, make sure to hit that subscribe button and ring the bell. The universe is getting a lot less darker every single day. Thanks for joining live. Thanks for watching, and I will catch you again in the next one.